All right, let's talk about one of the first things you ever learn in programming, the whole compiled versus interpreted debate. We all know the simple definition, right? Well, today we're going to tear that down because the real story is so much cooler. Let's dive in.
So here's the big question. Is it really that simple? Is a language like C++ always compiled and a language like Python always interpreted? Is it just a switch you flip? Well, as you've probably guessed, the answer is not even close. It's way more interesting than that.
Now, this is the classic picture we all have in our heads. On the one hand, you've got compiled languages. The idea is you translate the entire chunk of code into machine code before you run it. It's like taking a whole book, translating it from start to finish, and then handing over the finished copy. On the other hand, you have interpreted languages, where the code is translated and run line by line, in real time. Kind of like having a live interpreter whispering in your ear during a speech. It's a great starting analogy, for sure, but it is not the whole story.
Okay, and here's the twist. This is the core of it all. The whole compiled versus interpreted thing, it's not actually a property of the language. It's a property of the implementation.
This right here, this single quote, changes everything. Compilation and interpretation are properties of a programming language implementation, not of a programming language. This is the big aha moment. It completely reframes the whole conversation. We shouldn't be asking what a language is, but what a specific program does with that language's code.
So what on earth do we mean by an implementation? It's really just the program, the actual tool, whether it's a compiler or an interpreter, that takes the code you wrote and makes the computer understand it. It's the engine that brings the language to life. Grasping this is the key to unlocking the whole myth.
And here's the big payoff for understanding that. It means that, in theory, any language can be either compiled or interpreted. Yep, you could build a compiler for Python. You could write an interpreter for C++. The labels we use all the time are really just shortcuts for how a language is typically handled.
So, let's move from theory to practice. Let's look at the real world, because once you start poking around under the hood of modern programming languages, you'll see those nice, neat lines between compiled and interpreted. They just dissolve.
The truth is, most modern systems aren't strictly one or the other. They're not black and white. They're both. They use a hybrid approach, grabbing the best features from both worlds to get this awesome balance of speed and flexibility.
So what does this hybrid approach actually look like? Well, one of the most common ways to do it is to compile the code, but not all the way down to machine code. Instead, you compile it to an intermediate form.
Let's walk through this. First, you write your source code. Simple enough. Then, that code gets compiled into something called bytecode. You can think of bytecode as a sort of universal, pre-digested set of instructions. It's not for your specific processor, it's for, well, anything. And finally, a program called a virtual machine, or a VM, comes in and interprets that bytecode on your machine. See? It's a compile step followed by an interpret step. This is exactly how giants like Java and the most common Python implementation, CPython, actually work.
And the plot thickens. It gets even blurrier than that. For some languages, you can actually choose between different implementations. Some are compilers, some are interpreters. And then you have this absolutely brilliant technology called just-in-time, or JIT compilation. A JIT compiler is wild. It starts out interpreting the code so the program starts up fast, but while it's running, it's also watching for pieces of code that get used a lot, and it compiles those specific pieces into super fast machine code on the fly. It's the best of both worlds happening in real time.
Okay, so we've gone deep here. Why does any of this nuance actually matter? I mean, who cares? Well, you should, because understanding this stuff helps you really understand the tools you use every single day and why they behave the way they do.
So, let's wrap this up. What are the key things to remember? Number one, and this is the most important, it's about the implementation, not the language. Number two, most modern systems are hybrids. They mix and match. And number three, it's okay to use a shortcut like compiled language in a casual chat, but just remember, in your head, that the reality isn't a simple switch. It's a whole fascinating spectrum. And that kind of leaves us with one final thing to think about. If this whole distinction we were taught is really a spectrum and not a switch, how does that change the way we should talk about our code? How should we think about the tools we build with? It's a great question to mull over. Pretty cool stuff to think about.